So let's start with the first question. The body is moving with uniform acceleration and covers 15 meter in fifth second. Okay, these questions will be randomly. You have to decide and solve it. You already have the base prepared for it, so I'll not be giving any hints to you. So try solving this in fifth second, 15 meters in fifth second, and 25 meter in tenth second. So determine first the initial velocity of the body, and second one is acceleration of the body. So try to solve this question. I'll give you 2 minutes of time. Think on it and solve it. Am I audible to you all? Could you please confirm? Um, I can see uh, my pop-up is coming when I speak, so I think I should be audible to everyone. Could you please check, Rupali, your connection? Maybe something wrong from your side. Yeah, thank you. Yeah, I'll repeat the question. A body is moving with a uniform acceleration and covers 15 meters in fifth second and 25 meters in tenth second. Okay. Determine initial velocity of the body and acceleration of the body. Yeah. Yeah, solve the question. So make use of this they have given a distance covered in the fifth second and tenth second. So you know the value of distance. You make use of the distance and solve this problem. Yes, not that difficult. Okay, let me just help you with some hints here, so that you can work on it. What will be the so I am saying fifth second means after completing the fifth second and after completing the fourth second, if you know the distance and if you subtract them, we'll get the distance covered by the body in the fifth seconds. Okay, so that is the intention here of this wording. So distance covered in fourth and fifth seconds are given by the distance covered in 4 and 5 seconds are given by S4 is distance covered in 4 seconds. So that is S is equal to UT plus half of AT square. UT plus half of AT square. And then S5 is U into 5 plus half of AT square. Okay, so with this, you can say that this 15 is nothing but the S5 minus S4, and that is equal to 5U minus 4U plus half of A times 5 square minus 4 square. Okay, and this will give you some idea or the equation in between U and A. Okay, so it's a U plus 9.5 is equal to 25. Dharmesh, something wrong with the answers. Could you please check again? See, your acceleration is coming negative. What is the meaning of it? It's a deceleration. And do you think the body is decelerating here? No, right? What you can see here is uh, it is covering 15 meter in fifth second and 25 meter in the 10th second. Means uh, there is a positive acceleration. You can say there is no deceleration here. There is acceleration. Okay, so you should not get negative answer for acceleration. Is it clear, Dharmesh? Yeah. So if in tenth, if in let's say 10 second the distance is 10 meter or 5 meter, I would have uh, agreed with let's say negative answers, but in this case it's not the case. Okay, so it's you have to think on the question, look at the numbers, and then check whether our answer is let's say satisfying that or not. Okay, so let's write it as equation number 1. Similarly, this 25 I will directly write here. Similarly, this 25 can be written as uh, let's say S10 minus S9, and that is 10U minus 9U plus half of A time 10 square minus 9 square. No, sorry. Half of 8T square. Yeah, I think, yeah. 10 square minus 9 square. So what you will get ultimately equation. Are you getting this one? So here I think it is 4.5a and u plus, this is the first equation, 4.5a equal to 15. Second equation is u plus 9a is equal to 25. Just check it whether it's correct or not. Okay, we got some questions here regarding why I have written this 4 here. What is the meaning of this? A body is moving with a uniform acceleration cover 15 meter in fifth second, not in 5 seconds. Okay, in fifth second it covers 15 meter. Means you have to neglect or you have to subtract the distance traveled, let's say by that body in 4 seconds from the distance traveled by the body in 5 seconds, then only we will get the distance traveled by body in the fifth second. Are you following, Dharmesh? Why this S5 and S4 is considered, and I'm subtracting F5 minus S4 and equating it to 15? Yeah, okay, good. Shivam, are you getting it? Yeah, okay. So then let's follow it. So just check the numbers, okay? I have not calculated it, so just want to make sure it is correct. I think the first equation is correct here. Second equation is 10 square is 100 minus 81, that is 19 divided by 2, that is 9.5. Okay, so it should be 9.5. Okay, A is equal to 25. Yes, I think now it's correct. Okay, so now you got two equations and you just have to solve them. You will get the two unknowns. That's all. You subtract equation 2 minus equation number 1. So what you will get is 9.5 minus 4.5 is 5. A is equal to 10. So this implies A is equal to 2. And if you put in A value in any of the equation, you will get U is equal to 6. Okay. So that's all. 6 and 2 are the correct answers for velocity and acceleration. Is it clear? I don't think this is a difficult question, but none of the student have answered it. Uh, so think on it. It's just a logical question. You know the formula. So what is there from mechanics point of view? Mechanics point of view, only the formula you have. S is equal to ut plus half at square. The rest of the thing is just your numerical ability, right? Uh, the distance traveled, let's say in the fifth second or in the 10th second. So that is your numerical ability which you have to apply here to solve it. There is nothing much conceptual thing in this problem. So this question should be very, very easy to solve. Let me give you another question. A particle has initial velocity of 10 meters per second and an acceleration of 3 meters per second. Find the speed of particle after it has moved 100 meter second. The distance the particle moves during 4 seconds. Solve these two questions and tell me the answer. Okay, I'll give you 2 minutes of time. Okay, so we got some answers here. The speed is 26.46. Yes, correct, Shivam. Uh, and Navya. And 64 is the distance. Mm, yeah, but what is the question? The distance of the particle moved during fourth second, not in 4 seconds. Okay, Navya, you're partly right. 64 is the distance traveled in 4 seconds, not in the fourth second. Okay, so consider it. But the first answer is correct. That is 26.45. So let's solve this question. Initial velocity u is 10 meters per second, and acceleration is 3 meter per second square. Sorry, here 3 meter per second square. Okay. Then the question is the speed of the particle after it has moved 100 meter. Okay. So s is equal to 100, and you know it's a very simple equation. V square is equal to u square plus 2as. Okay, or v square minus u square is equal to 2as. It will where u is the initial velocity, v is the final velocity. So that's all. So initial velocity is 10. So 10 square plus 2 times acceleration is 3 and s is 100. So 10 square plus 2 into 3 into 100 is equal to 700, and under root of 700 will give you the value of v, that is 26.46 something. Okay, meters per second. So very simple question. And yeah, for the second question, yes, 20.5 is the correct answer, Dharmesh. Vaibhav, Abhishek, and yeah, most of you have answered it correctly. Yeah, so coming towards the second part of the question, that is distance traveled by the particle during 4 seconds. So you will again do S4 minus S3. Okay, so that is UT plus half of AT square. So it's 10 UT. So S4 is what? Let's write first S4. 10 UT. U is 10, 4 T is 4, UT plus acceleration is 3, T square means 4 square. So this is the S4 minus next one is again UT plus half of AT square, 10 into 3 plus half of A is 3, T square is 3 square. Okay, this is traveled in 3 seconds. Okay, so it's 64 minus 43.5, that is 20.5 meters. Okay, yes. Okay, let me give you one more question here. Maybe you can take it for homework and solve whenever you have some free time. A particle under constant deceleration. Okay, it's a deceleration problem. Constant deceleration is moving in a straight line and covers a distance of covers a distance of 20 meter in first 2 seconds. And 40 meter in next 5 seconds. Okay, full stop. Calculate the distance it covers in the subsequent next 3 seconds. Subsequent next 3 seconds. Okay, and the total distance it covers, and the total distance it covers before coming to rest. Okay, so yeah, the solution part. Answer for the first question is the distance is in the next 3 seconds is distance covered in subsequent next 3 seconds is 17.14 meter. Okay, and the total distance it covered before coming to rest is 97.78 meters. Okay, so this is the total distance, and this is the answer for the first question. Okay, so answers are given to you. You have to spend some time on it whenever you have free time and match it. Okay, I hope it's clear. Okay, I'll repeat the question if it is not. A particle under constant deceleration is moving in a straight line and it covers a distance of 20 meters in 2 seconds, 40 meters in next 5 seconds. And so slowly, what is happening is it is coming to rest, and the calculated distance it covers in the subsequent next 3 seconds. Okay, uh, so in next 3 seconds, how much distance it will travel, that you have to calculate, and also the total distance it covers before coming to rest. Before coming to rest means the final velocity will be 0 in that case. Okay, so try to solve it, and if you still have any doubt, you can free to reach out to me. Okay, so you can reach me or you can just post in the group, whichever you feel comfortable, and then we will either I will help or others can also pitch in and answer it. Okay. Okay, let's start with some other questions now. Okay, just a minute. Take one question. Body falling freely under the action of gravity passes 2 points 9 meter apart vertically in uh, 0.2 seconds. Stop. From what height above the from what height above the higher point did it start to fail? Sorry, yeah, did it start to fall? Okay, I'll repeat the question. So we have a body falling freely in vertically downward direction, and because of the gravity, and 2 points which are 9 meters apart. Let's say this is one and this is another point. These 2 points are, let's say, 9 meters apart. Okay, and it crosses like this 9 meter in 0.2 seconds. I hope you understood till this. From what height above the higher point did it start falling? So basically, this is what they're asking. This height, let's call it as S1. They're asking you to calculate S1. Is this question clear to you all? What is the requirement here? I have already drawn the diagram to help you, so I hope it should be clear. Yes, u is 0 because you have to assume you have to 0 because what they are saying is from what height above the higher point did it start to fail? It start to fail means it start to fall means what? It start to fall means initially it is let's say not falling. So u is 0 in that case, and then you have to solve it. Yes, Vaibhav, u is equal to 0 is the assumption, and that is because of this last sentence. No, Dharmesh. 2.2. No, no, wrong answers, all of you. Okay, let me help you out. So basically, if you're calling that S1, you can call it this as S2, right? So what they are saying is this S2 minus S1 is equal to 9. Very simple. And in how much time they are doing it? Uh, let's say in order to cover distance S1, it needs time T1, and in order to cover distance S2, it takes time T2. So T2 minus T1 is also given as 0.2 seconds. So this is the given data to you. Okay, so you have to think what equations we can make which will fit into this format. Okay, So let's try to solve it. S2 is equal to what? Ut is equal to half of Ut plus half of Ut1 plus half of GT1 square, and it is U is 0, so half of GT1 square. Okay, and sorry, this is let's call it S1, and S2 will be same. Ut2 plus half of GT2 square, and again here U is 0, so it will be half of GT2 square. So S1 minus S2 is 9, so 9 is equal to half of G, you can take common, T2 square minus T1 square, so it is T2 minus T1 into T2 plus T1. Okay, so A square minus B square is A plus B, A minus B. No, Abhishek, answer is wrong. Check again. So 1 by 2 into 9.81 into T2 minus T1 is what? 0.2, and it's T2 plus T1, that is equal to 9. So you will get an equation T2 plus T1 um, equal to how much? Solve this. 9 into 2 divided by 9.81 divided by 0.2 should get 9.17 something. 9.174. Okay. So you got this equation. You got this equation. Solve them. Add them together. So 2 times T2 is equal to 9.37. Okay. Something like this. So T1 you should T1 is 4.487 you should get if you solve this. Okay. If T1 is 4.478, what is S1? S1 is equal to half of GT1 square, that is 4.487 square, and G is 9.81. And how much? 98. Yes, nowhere 98.76 meters is the correct answer. Yeah, it was not that difficult. See, uh, the problem is same as what we have studied before, but here the motion is under gravity, so acceleration is because of the gravity. That is the only difference. Okay, is it clear? Any doubt? Okay, let me give you one more question. A particle falls from rest, and in the last second of its motion passes 70 meters. Full stop. Find the height from which it fell, and time, and the time of its fall. Okay, full stop. Take G is equal to 9.81 meter per second square. Yeah. Okay. Okay, maybe you can take this homework question because it's more or less similar to what we have solved. You should be able to solve it, and the answer is here is 286.1 meter. Okay, you take this question for homework and solve it. Final answer is 286.1 meter. Very simple question, should be able to solve. And still, if you find difficulty, you can feel free to reach out to me. Okay, some other questions I'll give to you. The motion of particle moving in a straight line moving in a straight line is given by expression given by expression s is equal to t cube minus 3t square t cube minus 3t square plus 2t plus 5, where s is the displacement, where s is the displacement in meter and t is in second. T is time in seconds. Okay, determine first is velocity and acceleration after 4 seconds. Maximum and minimum velocity and corresponding displacement. Maximum and minimum velocity and corresponding displacement. And time at which velocity is 0. Zero. Okay, so velocity and acceleration after 4 seconds. Yes, Pranjul, your answer is correct for the velocity 26 meters per second. Okay, so solve these questions, all questions, linked questions. You should be able to solve it. Yes, 26 and 18 is the correct answer for first. Okay, so let's solve these questions. So velocity and acceleration after 4 seconds. You already know S is equal to t cube minus 3t square plus 2t plus 5. So velocity is what? ds by dt is the velocity. Okay, and that is 3t square minus 6t plus 2. What is acceleration? dv by dt, and that is equal to 6t minus 6. And what they are asking is velocity and acceleration after 4 seconds. So 4 means what? T is equal to 4. You have to put. So velocity will be 3 into 4 square minus 6 into 4 plus 2, and here 6 into 4 minus 6, and if you solve it, 26 meters per second and 18 meters per second. Okay, is it clear till the first part? Yeah, most of you answered it correctly. Coming towards next question, maximum and minimum velocity and corresponding displacement. So what are the answers? Minimum velocity, maximum or minimum? Yes, it's a minimum velocity. Sorry, the wording is wrong here. Maximum or minimum. Okay, not and. Maximum or minimum. Yes, Abhishek, either maximum or minimum you can say here. And yes, -1 is the correct, because velocity is what? You know, velocity is 3t square minus 6t plus 2. And whenever we do maximization or minimization, we differentiate that function with respect to the independent variable and equate it to 0. So it's a dv by dt equal to 0, and that is 60 minus 6 equal to 0. This implies t is equal to 1. Okay, uh, so t is equal to 1. uh, yeah, and from any equation, let's say from the equation of velocity, if you put t is equal to 1, 3 minus 6 plus 2, you will get v is equal to -1 meters per second. Okay, so uh, minimum velocity is -1. And what about the third question? Is time at which velocity is 0. Time at which velocity is 0. Again, same equation you have to follow. Put v is equal to 0 and solve it for the time. Okay, so 0 is equal to 3t square minus 60 plus 2. Okay, and you can solve this. Okay, you can solve this. Let's say 3t square. So it's minus b plus or minus under root of b square minus 4ac divided by 2a. So it's minus b is how much? Minus of minus 6. So it's a plus 6 plus or minus under root of b square minus 4ac. 36 minus 4 into 3 into 2 divided by 2 times a is 2 times 3. So it is equal to 1 plus, because 2 multiplied by 3 is 6. So 6 will get cancelled, plus or minus, I think you should get 0.577. So either the answer is 1.577 or 0.422. Okay, either of so both are the answers here for the third question. Coming towards the doubt from Dharmesh, why I'm calling it as a minimum, because if you differentiate it again, d2v by dx dt square, what is it? It is 6, and that is greater than 0. Wherever double differentiation is greater than 0, you call it as a minima. Okay, hence minima. Okay, uh, if double differentiation is, let's say, less than 0, then the value at that point will be the, at t is equal to 1, will be the maxima. Is it clear? Maybe I think you might have studied this, or you will study this when the mathematics subject will start, and you will learn the calculus topic where the minima and maxima is there. Okay, so it is from the calculus mathematics where you will study the minimization or and maximization of single variable functions. Okay, I hope the question is clear to you all. Let me give you another question. If a body is moving in a straight line, okay, and its distance yes, and distance yes, s in meters from a given point, from a given point in in the line after t seconds is given by the equation s is equal to 20t plus 3t square minus 2t cube. Calculate. First is velocity and acceleration and at start. Okay, second, the time when the particle
So that is 2t cube or 2t?
minus 2t cube. So I'll repeat it. It's a 20t plus, okay, plus 3t square minus 2t cube. Let me write the t something different. T. Okay. Here also t like this. Yeah. 20t plus 3t square minus 2t cube. Okay. The second question, the time when particle reaches its maximum velocity, and the maximum velocity of the body. Yes, let's solve them. Velocity and acceleration at the start is yes, 20 and 6, correct, Abhishek? So question is very simple. S is given to you, 20t plus 3t square minus 2t cube, and velocity will be the distance differentiation of displacement with respect to time. So it's a d by dt of this. So it is 20 plus 60 minus 6t square. And similarly, the acceleration will be dv by dt, and that is equal to 6 minus 12t. And velocity at xt is equal to 0, velocity at t is equal to 0, and acceleration at t is equal to 0 is equal to what? 20 and 6. Okay, as simple as it. So first question is very simple. The time when particle reaches its maximum velocity. Okay, so think on it a little bit. So what is velocity? Velocity is 20 plus 60 minus 60 square. Velocity is 20 plus 60 minus 6t square. And the maximum velocity condition is dv by dt equal to 0. Maybe minimum or maximum, we don't know. So let's see. If you equate it to 0, differentiation of 20 is 0. So it's a 6t is 6 differentiation minus 12t equal to 0. So this implies t is equal to what? 0.5. And if you double differentiate, you will get minus 12, which is less than 0. Hence it is a maxima. Okay, so the point t is equal to uh, 0.5 is maxima. And now you can calculate. Yeah, I think they have just asked the time, right? So 0.5 is the correct answer in this case. Okay, the time when particle reaches its maximum velocity is 0.5. And the last one is the maximum velocity of the body. Yes, so you can still put this 0.5 into this and you'll get the maximum velocity. 20 plus 6 into 0.5 minus 6 into 0.5 square. Okay. 21.5 meters per second. Okay. So that's all. Okay. Let me give you another question. You can take it for homework. Okay. The speed of a body moving in a straight line is given by the relationship v is equal to 1.25 in bracket t minus t square by 10, where v is in meters per second and t is in second. Okay, determine analytically or determine the maximum acceleration and the distance traveled from rest in 10 seconds. Okay, so two questions in this. The distance traveled from the first one is the maximum acceleration, and second one is the distance traveled from rest after 10 seconds. Okay, so acceleration in this case is 1.25 meter per second square, and the distance traveled from the rest in 10 seconds is 20.833 meters. Okay, So take this question for homework and solve it whenever you have some free time. Okay. Okay. Fine. Let me give you another question. Solve it. A particle has an initial velocity of 20 meters per second. Okay. Particle has an initial velocity of 20. Okay. Is thrown in the air at an angle theta with the horizontal. The x and y coordinates of a point leave one. Okay, the x and y coordinates of a point uh, live on the trajectory of the particle with respect to point of projection are 20 meter and 8 meter respectively. The angle of projection theta is. Okay. The options are there, uh, but you can directly tell me the answers. You should get two answers here. Okay. Solve it. So this is on the projectile motion, which we have studied in the last class. So particle has an initial velocity which is thrown in the air is 20 meters per second. It's making some angle theta with the horizontal. The x and y coordinates of the point which lie on the or which lie less than lie you can say lie uh, on the trajectory of the particle with respect to the point of projection are 20 meter and 8 meters. Okay, respectively the angle of projection they are asking. Okay, let me help you with some figure to make um, you comfortable with this problem. Okay, so particle is thrown at certain angle theta with respect to horizontal, which and with an initial velocity of 20 meters per second. Okay, and after some time, let's say point of projections are 20 and 8. Let's enter this figure little bit better. Okay, so this is the point which is 20,8. Okay, yeah, I think now it's clear. You can make use of this figure to solve it. This is V naught, and V naught is 20 meters per second. Okay, solid. Yeah, any answers? 20 and 8. What is this 20 and 8? 20 is the horizontal distance traveled by the particle, and 8 is the vertical distance. So you know how to calculate the distance. S is equal to ut plus half of 8 square is the acceleration, is the distance formula for a constant acceleration problem. Here we are working with the gravity, so constant acceleration, and you can apply this s is equal to ut plus half of 8 square. And as we are throwing against gravity, the formula will change to s is equal to ut minus half of gt square. 42 is not the correct answer. Okay, 42 is not the correct answer. Let me help you with some solution. 42 is not correct, Shivam. Yeah. See, what is the horizontal component of the velocity? V naught cos of theta. Vertical component is V naught sine of theta, right? So V naught cos of theta is responsible for the horizontal distance of 20, and V naught cos theta is responsible for the vertical distance of 8. So what is 8? 8 can be written as Sy, right? And what is 20? 20 is what? Sx. Do you agree? Sx is 20 and Sy is 8. Till this, is it clear? Abhishek, no, answer is wrong. So in horizontal distance, we don't have acceleration, right? During the horizontal. So it is just the distance is equal, velocity is equal to distance divided by time. So distance will be is equal to velocity into time. So velocity is 20 cos of theta into time is uh, t, let's say. Okay. So t is equal to what? 20 divided by 20 cos of theta. 20 will cancel. T is equal to 1 upon cos of theta. Okay. So this, let's say, the point corresponding to the t is equal to 1 upon cos of theta. Okay, so at least we got the first basics, that is Sx, and now Sy. How to calculate Sy? So 8 is equal to Sy. Okay, as I said, Sy is equal to 8, and that is equal to what? V naught yt minus half of gt square. Okay, so what is V naught y? 20 sine of theta, and t into t minus half of g is 9.81 gt square, t is keep as it is, and t we have calculated. What is the value of t? 1 upon cos of theta. Put it here. So 20 into cos of theta divided by cos sine of theta divided by cos of theta. I can write it as a tan of theta minus half of 9.81 into 1 upon cos theta whole square is sec square theta. Is it clear till this equation? 8 is equal to 20 tan theta minus half into 9.81 into sec square theta. Any doubt till this? Now from this, can you calculate the theta? Yes, we can calculate. That is sec square 1 plus tan square theta is equal to sec square theta. So use that. 8 is equal to 20 tan theta minus half of 9.81 into 1 plus tan square theta. Okay, and what we'll get here is 8 is equal to 20 tan of theta minus half of 9.81 minus half of 9.81 into tan square theta. Assume tan theta as x. Okay, so 8 is equal to 20x minus 9.81 divided by 2 is 4.905, something like this, minus 4.905 x square. Okay, so 4.905 x square minus 20x. Sorry, this should be check the signs. Let me just so solve this. 8 uh, okay. Let's correct it if I'm wrong. Okay, this is how the equation will look like, I think. Is it correct till this? Vaibhav, you also got the same equation. 4.905 x square minus 20x plus. Okay, yeah, and if you solve it, you will get two out. Sorry, two answers you should get here, right? Because it's a minus b plus or minus b square minus 4ac. And so what was the value of x here, Weber? You should get two values for x, and that so it means it is the value of tan of theta, and finally value I think tan theta you should get as 20, 72 and 38.7. Okay, I think these are the two final answers. Just check, solve it on your own. Okay, but you should get the value here. There should be two different values. What is the other value? Anyone else? Yes, 38 is the correct, Abhishek. And another one is also 72. Okay, so there are two answers, 72 and 38. So just calculate this x from, solve this equation, get the value of x equal to tan theta, and you will get the answer. Okay, we got some question from nowhere. Isn't it s is equal to v naught sine of theta minus gt minus half of. Now, yeah, what is the formula for s? S is equal to ut plus half of at square, right? So vertical distance sy, which is 8, that should be equal to what is velocity which is causing, what is initial velocity which is causing vertical displacement. So that is u naught sine of theta, and what is u naught? U naught is 20. So that is why 20 sine of theta, and t as it is I am putting, okay, and minus acceleration is coming downward. So it's that is the reason minus we are writing, and acceleration is g, which is acceleration due to gravity, t square, and that is the reason I have written it as 20 sine of t minus half of 9.81 into t square. No, Navya, s is not v1y minus gt square. Okay, s is equal to, what are the formulas? S equal to ut plus half at square, v is equal to u plus at, and v square minus u square is equal to 2as. I don't see anywhere the similarity which you have written. U will always come in the equation whenever you deal with s. So this is the equation, s is equal to ut plus half at square, where this general equation, what is meaning of u? U is the initial velocity, right? I am not writing s is equal to vt plus half of at square. We have derived it previously, if you remember. U is means initial velocity, v means final velocity. Okay, and here initial velocity is v naught, and the vertical component of it is v naught sine of theta. So that's why 20 sine theta into t I have written for ut. Okay, so everyone got the answer? Okay. Let me check if you have any other question. Okay, otherwise I'll just introduce one small point: fixed axis rotation. Okay, uh, write down heading fixed axis rotation. Okay, draw one circle. Okay, let's draw one circle. Okay, this circle is of radius r. Okay, and let's say a particle is moving along this fixed axis. Okay, so this is the axis, O is the axis, for example, of rotation, and the particle is rotating this with a fixed axis in a circular motion, which is of a radius r. And let's say the distance traveled by the particle is from this point till this point is s, which makes an theta angle. Okay, from the origin or the axis, and as it is moving in this direction, the okay, uh, okay, at is tangential acceleration, or v is the velocity. Basically, velocity is always perpendicular to the function, or perpendicular, sorry, velocity always tangent to the function, or um, this circle in this case. Okay. So what is this distance as? S is equal to r times theta. S is equal to r times theta. So if you differentiate it as ds by dt, that is what your angular velocity. Okay. Um, so basically it is r is constant and this d theta by dt you can say. Um, so ds by dt is your linear velocity and that is equal to r times the angular velocity. Okay. Uh, r omega. R is constant, radius is not changing, so only thing which is changing is theta. Angular displacement with respect to time, that is angular velocity omega. The unit is in radian per second. So what is omega? Omega is a rate of change of angular displacement. Rate of change of angular displacement. Okay, with respect to time, and that is given by radian per second, which is d theta by dt. Okay. What is this AT? If you differentiate the velocity again, dv by dt is equal to, let me go to the next slide to perform the derivation. What was v? V is equal to r omega. Okay, so what is dv by dt? Is r times alpha, that is d omega by dt. Okay, so dv by dt is tangential acceleration, that is an r alpha. Okay, so what is this alpha? Alpha is, you can call it as an angular acceleration, that is d omega by dt, which is radian per second square. Okay, uh, and r is the radius. Okay, you can call this angular acceleration as rate of change of angular velocity. Velocity with respect to time. Okay, and what is this AT? AT is the tangential acceleration. Okay, which is in meter per second square, and it is generated because of change in the magnitude, change in magnitude only of velocity with respect to time. Okay, so the tangential acceleration component is coming only because of the change in the magnitude of the velocity. Okay, change in the velocity with respect to time will give you the um, tangential acceleration, and it is always if it is acceleration, it is along the velocity direction. If it is deceleration, it is just in the opposite direction. Only the arrow will change. So you can see AT I have drawn, tangential acceleration I have drawn along the same line of the velocity. If it is a deceleration, I'll just change the direction. Okay, like this. That will be AT. If it is a deceleration, I hope it is clear. Okay, but yeah, the general situation is like this. If body is accelerating, this is how we can draw the velocity component and tangential acceleration component. Okay, but apart from AT, there is one more acceleration that is called as a normal acceleration. Okay, so write down heading an, that is normal acceleration, and why it is coming, because of why it is generating. It's generating because of the change in the direction. Okay, so it is, let's say, generated because of change in direction only of the velocity of the velocity with respect to time. Okay, with respect to time. And what is its value? An is given by r omega square. Okay, and omega is equal to v is equal to r omega, so omega is equal to v by r. So you can also write it as v square by r as well. Okay, meter per second square. Okay, so this is the formula which we can use. Okay, what till now what I've explained is ATA and VT. Okay, AT and V are in the same direction, then the acceleration is there, so it means it's increasing. And if it is in opposite direction, means deceleration is there. So that's all about the tangential part of the acceleration. Coming towards the normal part of the acceleration is generated because of the change in the direction uh, of the velocity with respect to time. Okay, and we know total acceleration is generally it's under root of tangential acceleration plus normal acceleration. Okay, okay, and where a is the total acceleration, or you can also call it as the resultant acceleration. Okay, this will be the more correct. Why this 80, half of 80 is sorry, why we write it as under root of 80 square plus an square? Let me just help you with this drawing. So I'll remove the velocity just to make this figure simply simplified. Okay. Hmm. So let's say this is 80. So vertical component of the 80 is 80y. Horizontal component will be 80x. Okay. So if this is theta, this also has to be theta. I hope you agree, because uh, for the horizontal line, this vertical line is perpendicular, and for this inclined line, this tangential acceleration is perpendicular. If angle between two lines is theta, angle between their perpendiculars should also be theta. Okay, so that is the reason I have written theta there. So now 80x and 80y, and similarly we have, let's say, an normal component of the acceleration, y, and this is x. Okay, so you apply the equations of equilibrium, and what you can conclude out of it is uh, 80y has to be equal to ny, and 80x has to be equal to nx. Or no, not like this. Rather than writing this, total acceleration, if you calculate, uh, not equation of equilibrium, because body is moving, we cannot directly apply equation of equilibrium, and we are not at that point. So uh, I'll not introduce it now here. So just assume that ax is the total acceleration along the horizontal direction. That will be what? atx plus anx. Okay, this is the total acceleration along the x direction. What is the total acceleration along the y direction? That is aty minus any. Okay, and that may change, right? I'm this for this particular point I am drawing. So if the point is different, the arrows will be different, stuff will be different. Okay, but as of now, ax and ay will look like this if you take any point. Okay, if you take this point and if you change, the equations will little bit change, but ultimately stuff will remain same. So what is atx? Atx is at sine of theta, and what is anx? En. So this is theta, this also has to be theta. En cos of theta. Okay, the plus sign here. And then we have aty, so at cos of theta minus any is an sine of theta. Okay, I hope you did it. And take the square of it, at square and ax square plus ay square. You know, resultant acceleration is always equal to a sum of all the accelerations in the x direction and y direction. And what was our ax? At sine of theta plus en cos of theta whole square plus ey is at cos of theta minus an sine of theta whole square. Okay, and this is our a square. And now if you simplify this, what you will get is at square sine square theta a square plus b square plus 2ab an square cos square theta plus 2at an sine of theta cos theta. Okay, plus second bracket at square cos square theta plus at square an square an square sine square theta minus 2at an sine of theta cos of theta. Okay, so if you add these two things will get cancelled, and at square if you take common, sine square theta plus cos square theta is equal to 1. So at square into 1 you will get. Similarly, if you take en square common, you will again get the cos square theta plus sine square theta, and that is 1. So at square plus en square is equal to the total acceleration a square. So a is equal to under root of at square plus en square. Okay, I hope it is clear. Okay, so you can directly use it, no need to remember the derivation and all, just for your information how it is derived. You should know the background of it. That is the reason I have explained this. Okay,
So,
yes,
so can you explain normal acceleration again?
yes. See, whenever let's say a body is there, okay, which is revolving around the fixed axis. So there are two things which are changing. Okay, it's not happening in the straight line, but in the fixed axis rotation, not only just the velocity is changing, which is developing the acceleration, but the direction also changing. Direction of the velocity is also changing with respect to time, right? And some component of the velocity, or let's say uh, that brings one component of the acceleration. So you can call it as, let's say, centripetal acceleration. Okay, and which you can feel if you take a thread and let's say at one end you just tie one stone or some heavy thing and just rotate about the fixed axis, the string, you can feel some force, okay, or along the let's say string, okay, and that is because of the tangential acceleration. Uh, that force, like centrifugal force, in you might have studied it, uh, but ultimately what uh, uh, that force is like because of some acceleration, right? And that is coming from this normal acceleration. Okay, so the normal component of acceleration is mainly because of the change in the direction, and the tangential acceleration is because of the change in the magnitude of the velocity. So the normal acceleration is always towards center. Okay, tangential acceleration may be along the velocity or may be opposite to velocity, depending on whether we are increasing the velocity or reducing the velocity. Okay, so I hope it's clear. Let's solve some questions so things will be more clear. Yeah, okay. Take a question. The rotation of flywheel is governed by the equation omega, okay, is equal to 4 root of t, where omega is in radian per second and t is in second, full stop. If theta is equal to 2 radian, when t is equal to 2 when t is equal to 1 second, the value of theta and alpha okay, when the t is equal to 1 second, the value of theta and alpha, okay, value of theta and alpha when t is equal to 3 seconds. Okay, is okay. What is alpha here? I'll explain. Okay, uh, alpha is, you can say, the yeah angular acceleration. I think I have already explained. Let me just check here. If not, yeah, alpha I have already explained. Angular acceleration. Okay, so it's a rate of change of angular velocity. Okay, so this alpha I'm talking about. Okay, just a minute. The slides are not responding. Take this question. The rotation of flywheel is governed by the equation omega is equal to 4 root t, where omega is in radian per second and t is in second. If v is if theta is equal to 2 radian when t is equal to 1 second, okay, the value of theta and alpha when t is equal to 3 seconds is, okay, solve it. Anyone? Theta is 13.85. Yes, correct. And the alpha is 1.15. No, 1.15. Let me just check. Maybe correct. Uh, yes, correct. 1.15. Yeah. Okay, now we're right. Let's solve this. You know, alpha is what? D omega by dt. So omega is already given 4 root t. So that is d by dt of 4 into t raised power 1 by 2. So 4 as it is, differentiation of t raised to power 1 by 2 is 1 by 2, t raised to the power minus 1 by 2. So that is 2 divided by root of t. And t is equal to 3 seconds they are asking. So 2 divided by root 3 is the final answer for the alpha, and that is 1.154 something. Okay, radian per second square. Coming towards the second part, that is value of theta in this case. You know, omega they are giving, which is nothing but the d omega d theta by dt. Okay, so and if you just integrate it to get the theta, it's integration of 4 t raised to the power 1 by 2. Okay, with respect to dt, and that is equal to 4 into t raised to the power 3 by 2 divided by 3 by 2. So it is 8 by 3 plus c. Okay, 8 by 3 t raised to the power 3 by 2 plus c is the value of theta. They have mentioned that if t is equal to 1 second, theta is equal to 2 radian. 2 is equal to 8 by 3 into 1 raised to the power 3 by 2 plus c. This will give you the value of c. So 2 is equal to 8 by 3 plus c. So c is equal to 2 minus 8 by 3. So that is minus 2 by 3. Okay. So finally we can say theta is equal to 8 by 3 t raised to the power 3 by 2 minus 2 by 3, the value of c. Okay. And what they are asking is the value of theta at t is equal to 3 seconds. That is 8 by 3, 3 raised to the power 3 by 2 minus 2 by 3. And that is 13.2 radian. Okay. Yeah. Most of you have answered it correctly. Okay. Let me give you another question. When the angular velocity of 4 centimeter diameter pulley is 3 radian per second, full stop. The total acceleration of point on its rim is 30 centimeter per second square, full stop. Angular acceleration of pulley at this instant is okay. When the angular velocity of 4 centimeter diameter pulley is 3 radian per second, full stop, comma, sorry, the total acceleration of the point on its rim is 30 centimeter per second square. Angular acceleration of the pulley at this instant is okay. So angular acceleration radian per second square. What they have given is omega, which is 3 radian per second. Total acceleration is 30 centimeter per second square. Okay, so this is the given data. So use this given data in order to solve this question. No, Abhishek, 24 is not correct. Maybe you might have calculated the tangential acceleration, not the angular acceleration. Check it again. No, 2.7 is not correct, Weber. Okay, I'll give you one more minute, solve it. Yes, Abhishek, 12 is the correct answer. Let's solve it. They have given us the total acceleration. What is total acceleration? That is square of tangential acceleration, normal acceleration, and root of it, right? And what is tangential acceleration here? That is equal to r and alpha. Okay, and so that is what we need first. We have to calculate alpha. In order to calculate alpha, we should calculate AT. What is normal acceleration? That is r omega square, and that we can easily calculate. 2 into the diameter is 4, means radius is 2. 2 into omega is 3. 2 centimeter, so 2 into 10 raised to power minus 2 into 3 square will give you the value of 9 into 2, 18 into 10 raised to the power minus 2 meter per centimeter square. Meters per second square is the normal acceleration. Total acceleration is given 30. So if you just put this value here, 30 square minus 18 into 12 raised to the power minus 10 raised to the power minus 2 whole square. If you do and take a root of it, you should get it as 24 centimeter per second. Okay, so or you can, since you can write it as 18 centimeter per second square as well. So let's keep it in centimeter per second square as of now. Okay, because if you just do 18 into 18 plus 24 into 24, you should get 900, which is square of 30. Okay, so I hope till this it is clear. 80 is known, and this is equal to r alpha, so 2 times alpha. This implies alpha is equal to 12 radian per second square. Okay, yeah, okay, no way. Yes, 12 is the correct answer. Okay, let me give you one more question. You can maybe try now or during your free time. Let's take it. The end day of the rod has a rightward component of velocity of 2 meter per second and an upper component of acceleration of 4 meter per second square, full stop. The angular acceleration of the rod at the position shown is. Okay, so let me help you out with the figure here. What they are trying to say: the end day of the rod has a rightward component. So this is the end day. Okay, this point is end day. Okay, the rightward component of the velocity is Vx is equal to 2 meter per second. It's a given, and the upper component of the acceleration is, that is Ay, which is 4 meter per second square. Okay, this is the given data. We only have information, so this is the x-axis, this is the y-axis, right? So along the x, we can say the rightward component of the velocity, which is 2 meter per second, and upward component of the acceleration is 4 meter per second square. That is given to you, and the angular acceleration of the rod at this position is. So what is the position? So let me just show you the position. Here the rod is of 10 meters, and the slope is 4 and 3. Okay, so accordingly you can calculate the theta and solve the problem. Okay, so we are at the end, so I would say you try it at home whenever you have some free time. Alpha you should get here as 0.53583 radian per second square. Okay, we will solve this question if you want in next class, in tomorrow's class. Let me know if you find it difficult. I'll help you to solve. Okay, no need to worry. Just remind me if you are not able to solve it. Okay, so solve this question. This is 90 minus theta. Then let's say if perpendicular to this, it should make for this is also theta. Okay, this for your information. You should and en is so 80 will be in this direction, right? And the n will be in this direction, and this is also theta. Okay, so you can make some conclusions out of it. I have already drawn you the diagram. The point A is this rightward combo. Let me use another pen, maybe black pen. So point A. Okay, point A is here where I have drawn the arrows. Sanjeev, is it clear? This is the point A. Yeah. Okay. So this point A, I have already given you the directions of normal acceleration, how the tangential acceleration will look like. You have to think. I don't know whether it is in this direction or in downward direction, but somewhere along this direction, which is perpendicular, right? So somewhere along this line, there will be tangential acceleration. And somewhere along this direction, velocity will be there. You think velocity is given in rightward direction Vx. So what should be the value of where should be V? So you can directly see V should be in this direction, right? Then only the horizontal component will come rightwards. And then this is your Vy. Okay. Vx and Vy. So similarly, you can have Anx, Any. Okay. And for At also, you can write Atx and Aty. Okay. And then make use of this given data and solve the question. Okay, so I have given you enough hint to solve it, and the final answer is 0.583. So 583, okay, radian per second square. Okay, any doubt in this question? Will you be able to solve it? At least try. And if you face any difficulty, we'll discuss it in the next class. Okay. Do you have any doubt? Tell us, is it clear to you all? Yeah. Okay, if no doubt, then we will end our session here. Thank you all for joining this class, and let's meet again tomorrow. Thank you all. Bye.